All right, in this question, what we've got is we've got Mr. G driving his car and a deer runs out on the road 60 meters away. Mr. G's reaction time is 0.2 seconds before he hits the brake. So he's driving along, nice constant 80 kilometers per hour. He sees a deer and it takes him 0.2 seconds just to get his foot, from the gas pedal over to the brake pedal. So he hasn't started braking yet for that 0.2 seconds. Once the brakes are activated, the car slows at this rate. And the question is, does he hit the deer? All right, let's just draw a little diagram of what's going on here. We've kind of got this 60 meters. Let's say this is the deer here. So I'll say deer here. This is the car here, but this is where he first spots. This is where he first spots the deer. When he first spots the deer, he still drives for 0.2 seconds. Okay, this is where the braking begins. Okay, so right here. So in here, we've got a time of 0.2 seconds. Let's say down here, delta t, this is not very much room, but delta t, 0.2 seconds, kind of right in here in this time. Over here, we're not sure what the time is. We do know that he's going this constant 80 kilometers per hour right here at the beginning, which means if it takes 0.2 seconds before hitting the brakes, I'm going this 80 kilometers per hour the whole time. Okay, so V in here is nice and constant. Let's see if we can get this a little bit. V is 80 kilometers per hour. That is nice and constant. No slowing down, no speeding up, anything like that. The question in here is, what distance do I cover? That's not actually the question, but that's something I need to know. What distance do I cover? Okay, that's up until here. Now, once that is over, then I start hitting the brakes. Okay, so what that means is my V1 in here is still 80 kilometers per hour. Remember, this is V1, this is right here at this line. I have yet to hit the brakes. This is where my foot first touches the brakes. That's where I begin to slow. So here my acceleration is 4.6 meters per second squared, and I'm gonna throw a negative in there. Just as a reminder, we are slowing down. Okay, so I'm going forwards this way. I'll say forwards this way is my positive direction. My acceleration then is negative forward, or just negative is fine. Now, eventually I'm gonna stop, and the question is, do I stop before the deer, at the deer, somewhere after the deer? I'm not sure. So I'm gonna put a line here and say right here, my V2 is 0. Okay, so V2 is 0. That's right here. I'll say V equals 0. I actually don't know that it's here though. It could be somewhere out here. Over this, I travel some distance as well. I'll call that D2. Really, my question is this. Does D1 plus D2, is that less than the 60 meters? Remember, from the car to the deer is 60 meters. Let's say 60 meters. That's all the way to the deer. And the question is, does this D1 plus D2, the distance that I actually cover, is that less than 60 meters, in which case I do stop here, or is it greater than 60 meters, in which case I wouldn't stop until here, which must mean I would have hit the deer? Okay, so that's our goal, is to kind of find out what is D1 plus D2. So let's see what we can find. Here it looks like some good kinematics. I've got 3 things I should be able to solve for D2. Over here, just remember, this is a constant 80 kilometers per hour. What that means is acceleration is 0. So let's look at kind of this first part. Let's look at, this is part 1, this is part 2. Let's look at part 1. And let me make sure you can see this. So for part 1, I know those 3 things. I'm looking for distance. We could say, for example, this equation. But remember, if acceleration is 0, that whole thing goes away. This really just looks like average velocity is displacement divided by time, right? It's just that equation. So I'm gonna call this D1. V is, now this is 80 kilometers per hour. I don't like that 80 kilometers per hour. Let's convert that. That V, let's squeeze it right in here. V is 80 kilometers per hour. I worked it out, is 22.2 meters per second, at least approximately. So let's put that in here, 22.2 meters per second times my 0.2 seconds. D1 then is about 4.4 meters. And And we can kind of do this and do section 2 over here. We also need to know what the distance over here is. A couple different ways I guess we could do it, but let's say the one that pops into my mind first is this guy. V2 is 0. 0 squared is still just 0. Again, 80 kilometers per hour. I'm going to use this 22.2 meters per second. 2, remember acceleration is negative 4.6. And D, this D here is actually D2. We can multiply this and bring it over here, so this would be 9.2 D2. And this thing here, 493.83. We can rearrange solve for D2. D2, 53.68 meters. Both of these are positive, so really these are displacements. You could say this is forward and make this into a displacement. Same thing here, this is a displacement, it is forward. We don't really need that, we're just really talking about distance. What distance do I cover? So D total. The D total that it takes me from when I first notice the deer to when I stop, so D1 plus D2. D total to come to rest is 4.4 plus this 53.68. D total 58.1, at least approximately 58.1 meters. If that's the total distance, where is that 60? Here it is. That's less than, so less than 60 meters. Okay, this is my stopping distance. My stopping distance is less than the 60 meters where the deer was, which means my diagram is kind of correct here. I stopped before the deer. So remember, when you have a question like this, just kind of go back to the actual question and check. Did I answer the question? I'd say no. He doesn't hit the deer. Doesn't hit the deer. And I don't know, if you really wanted to, the question is just being a little bit cheeky here, but no venison burgers. Venison is deer burgers. Venison burgers tonight. No venison burgers. To kind of make sure we've actually answered the question. Where is it? There we go, on the screen. And there's our solution.